Boy, I've just missed you. I'm so glad to see you here, and I'm glad we're back, continuing what we did last video. Oh yeah, let's go. So here we are, just picking up where we left off from my last video. Like I said, Flexplot has some amazing, incredible, lovely, beautiful functionality. And so, of course, in order to access that, we need to require Flexplot. The current version that I'm using, I believe, is 0.17.2 or something like that. If you're far from that, you may need to update Flexplot because some of this functionality might not be available unless you do. So yeah, there's that. So the first function we're going to look at is the estimates function. So in my last video, I fit a model where I'm looking at anger and emotional bonds, both as fixed and random effects. And then if we look at estimates, it's going to give us a lot of the same information. So that's not terribly helpful, you might be saying. But oh, you just wait. Oh, you just wait. Okay, so we get our intercept and our fixed effects, which are the same as when we did the summary statement. And we also get the random effects, which, again, that's the same as the summary statement. So what's the deal here, Fife? You're going to show us something new? I've seen that before. That ain't new. Oh, you are right. But have you seen this? Bam! Bam, bam, bam! You haven't seen the design effect. You haven't seen the ICC. You can't get that from summary. You can only get that from Flexplot. I'm losing my voice. All right.
Excuse me. I can't see the numbers. Your head's in the way.
Oh, dear. Is that better?
Yeah, quite a bit. Thanks.
All right, let's try that again. So I'm going to run the estimates function. Oh, yeah. So, yeah, like I said, this is the new stuff that we couldn't find from using the summary function. Oh, yeah, we're amazing. We're awesome. Yeah. So we get two things that are kind of important, the ICC and the design effect. The ICC stands for the intra-class correlation. And basically, it's a measure of how correlated people are within a cluster. So let's say our cluster is individuals. So we've got, in this case, well, Jedi being measured multiple times. It's a measure of how correlated individual Jedi scores are with one another. So a value of 0 means there's no correlation within cluster, and high values indicate there's a high degree of correlation. And so this seems to be on the lower end, but the ICC also is able to pick up these things pretty well. Really what you want to look at is the design effect. So what is the design effect? So remember in a previous video I said one of the problems with ignoring that clustering is that it's like artificially inflating your sample size. And so the design effect actually gives us a measure of how much we've inflated our sample size. And so 5.53, if I'm rounding, basically says that if we were to run this model as a regular model, we would artificially increase our sample size by a factor of 5.5, basically. So it would be like making 5 copies of our data set and running the exact same analysis. And so, of course, we would get statistical significance, and of course, we would get really high base factors and AICs and BICs and all that. And so that tells us that mixed models are really necessary. If that was at 1, then that'd say, all right, your design effect is 1. It's like multiplying your data set by 1, or sample size by 1, which is the same as whatever your data set is. But this certainly indicates that mixed models are absolutely necessary. Otherwise, we would make lots of terrible conclusions. So yay for us for doing mixed models. Bam! All right, and then we get R squared. I'm not going to go into too much detail about what this means, but long story short, you can sometimes get negative values, and you just basically treat those as if they're 0, because that doesn't make sense. And then the residual values, we essentially interpret it like we would a regular R squared. So remember, an R squared gives us a measure of how accurately we're predicting the individual data points. And likewise, this is the same here, except we have individual data points that are at the cluster level. So it's basically saying how accurately are you able to predict the individual data points. And as we add more predictors, usually that goes down, but not always. So that's the estimates function. Now, what else can we do? Flexplot does more than estimates, am I right? Yeah, it totally does visuals. That's like its forte. So let's go ahead and bring this up here, and we're going to visualize that model. And I'm just going to say plot equals model, And I'm going to see what Flexplot comes up with. There it is. And to keep my head out of the way, I'm going to click on the zoom button. And so let me explain what's going on here. So model, when we say visualize model, basically Flexplot is like, all right, cool, I'm going to visualize it. Here's the deal, though. You've got two predictor variables, anger and emotional bonds, and you got a cluster variable. I need to plot all those. I don't know how you want this plotted because you didn't tell me. And so I'm going to make some decisions. I hope you're okay with that. And for the most part, it has some logic behind it, and the plots that we look at are going to be fine. And so you can very easily visualize them without adding any additional arguments. And this is what we get. And Flexplot decided, that anger score looks pretty nice. I'm going to put that on the x-axis. Emotional bonds look pretty nice too. I'm going to put those in panels. Hey, wow, look at that. The cluster variable, Jedi ID, I'm going to put that as a separate color, line, and symbol. And so what are we wanting to look at here? Of course, that's probably your first question. All right, what am I looking for? What you're looking for is to see if these, not the thick lines. The thick lines you don't care as much about at this point. You're looking at the thin lines and trying to say, does that actually make sense? So I'm looking at these blue squares. I'll make that bigger for you. How's that? Can you see a little bit better now? Woo, okay. So we got all those squares, and it looks like that line passes right through the data. And there isn't any indication that there might be a bend to the data, so hey, that's looking pretty good. The other lines we can't see because they're like directly over the fixed effect line. So the green line here looks like that's fitting pretty good. It's possible that there might be a curvilinear effect, but it's probably just because of that dot that I'm thinking that. Otherwise, it looks good. That blue one looks good. It looks a little biased towards the center, so I might think it should go right there, but that's actually what mixed models do. They tend to bias the individual lines toward the center black line, and that's cool. So I'm looking at this, and using the visualize function, I've decided, hey, my model's doing pretty good. High five, model. You rocked it, man. You know what? You deserve a break. Go take some time off. Buy yourself some ice cream. So good job, model. Now, you might be saying, wow, that was cool and all, but I really envisioned that instead of anger on the x-axis, I really thought that it would make more sense if emotional bonds was on the x-axis. So, my dear Flexplot, can you replot that, but put emotional bonds on the x-axis, and then this time put anger in the panels? And Flexplot will say, nothing. It'll just do it, because that's how Flexplot rolls. So, again, we're looking for the degree, and we probably wouldn't have to look at it from multiple angles, but it's not a bad idea to do it. So we got a different plot, and things are looking good. The lines seem to be passing through the center of the data. It looks like we have a good model, so yay. And one other thing that I'll point out, probably should have pointed this out earlier, but that's okay. It's not looking at all the Jedi, because I don't even know how many Jedi we have, but let's say we have 100 Jedi. It would be massively informationally overloading if we plotted all the Jedi at once. So it's randomly sampling. So if you were to follow along with me and do this, which you're totally welcome to, the dataset is linked in the description, you would probably have different Jedi selected. And that's totally cool, because that's what Flexplot is doing in the background, is it's randomly selecting Jedi, just so you can get an idea of what it's looking like. So I might write a note to myself, hey, dude, have I told you lately how handsome you are? BT dub. These look great. The model seems to be fitting the data well. Now go have yourself some ice cream. Man, this is the second time I brought it. Apparently, I have a hankering for some ice cream. Okay, so that was cool. We saw that at the individual level, from the individual data points, the model seems to fit well. So you might also, we made the decision earlier to allow the slopes to vary randomly. So you might say, you might want to use a visual or use the visualize function to see if that's really merited. So what we're going to do is we're going to specify the formula a little bit differently now. We're going to get rid of the paneling. So in this case, it was anger. So we just got rid of anger, and now we're just doing emotional bonds on Jedi ID. But this time, we're going to sample 30 people. So we got rid of the paneling because that'll just be a lot of information. to display all at once. And really what we're trying to see is how much the slopes vary. So we don't need that panel. And instead, we're going to look at 30 different Jedi and see what that looks like. And if we do that, what does Flexplot say? It gives you two notes. One, you didn't choose to plot anger, so I'm inputting the median. That's cool. And then it says, it looks like you're trying to plot more than 6 colors, lines, symbols. I got to give it to you. You're ambitious. Alas, I can't do that. So I'm removing the colors, lines, and symbols. I hope we can still be friends. Oh, isn't Flexplot so sweet? So basically what it's saying is when you put Jedi ID as the second slot in a Flexplot formula, you are telling Flexplot to give me a unique color, line, and symbol for every single instance of whatever that variable is. Well, we have, in this case, 30 freaking Jedi. You're asking it to give you 30 unique values? Are you kidding me? Give it a rest. I mean, think of it from Flexplot's perspective. That's hard. You know, we really need to be compassionate. Sorry, I'm going crazy. So yeah, basically Flexplot is saying, I can't give 30 unique ones. Sorry, but that's okay. We don't need that. So if we look at this plot, what am I looking for? I'm looking to see the degree to which the slopes are parallel to that fixed effect. Because if they're all basically the same thing, then I may not need to model a random effect. But as I look at it, we've got this really steep slope right here, and we've got a negative slope right here. So I would be inclined to say, yeah, those slopes really do vary, and we need to model that. So I'm not even going to bother doing like a model comparison or anything. But let's go ahead and look at another plot. So that was for emotional bonds. Anybody watch Stephen He? Emotional damage. Good YouTube channel. You should totally check it out. But emotional bonds. So that was emotional bonds. Now we're going to look at anger. And if we plot that, it's going to give us the same message. And this looks a little closer. We still have variation, but is that just noise? For the most part, most of those slopes looks like it could be that a fixed slope might work. And so, look at that. Looks like anger might not need a random effect. Let's do a model comparison. And that brings us to the next Flexplot function we could use, a model comparison. But wait, no, I know you're excited about that, but we're going to have to wait a little bit because I'm going to use the compare.fits function. Why? Because I usually prefer to visualize things before I start looking at numbers. So what am I going to do? I'm going to fit a new model called reduced. Did I already say that? I don't think I did. So I'm going to fit a new model called reduced, and the only difference between this and the full, it has the same fixed effects, but now it only allows emotional bonds to vary. So I've removed the random effect for anger. So if I run that, and then now if I do a compare.fits, and I'm just kind of randomly making up an equation. So I'm putting anger on the x-axis. No, actually it's not random, it's intentional. I'm putting anger on the x-axis because that's the variable that I am changing, I guess. Although I'm not sure that it matters much. And then you got data equals D. I'll go ahead and put those on separate lines just so it's easier to see the arguments. And then this is the important one. If we go RE equals true and new Flexplot today, update that launched today, what? Is that this will actually work. This is the second time I've recorded. This is the second time I've recorded this video and the first time it did not work. So if I do that, and if we now look at the plot, what do we see? Ha ha ha! You, Dustin Fife, forgot to update Flexplot. Oh, let's go ahead and do that right now. Dev tools, install _ GitHub. Dustin Fife / Flexplot ref equals development. And maybe by the time you watch this video, I will migrate those into the other one so you don't have to do ref equals development. But I'm just going to go ahead and hang out here while Flexplot installs. And we're done. Boy, that was fun. Okay, so now I'm going to get rid of that. And actually, I probably should restart R because oftentimes the changes won't be reflected. Let me see. Yeah, it won't. So let me restart R and then be right back.
We're restarting our. We restarted our.
I'm going to go back and load the things that were not loaded before. And then my full model. There you go. Require Flexplot. There we go. And then fit my reduce. There we go. Compare.fits. There we go. And yep, now it's working. So now we have the red line represents the full model. I probably should have named it full instead of model. The blue line represents the reduced model. And so based on this random sample of 3 Jedi, actually, you know what? I think I'm going to change that. We don't need emotional bonds in there. So I'm just going to do Jedi. And I wonder, I don't know if this will work, but I'm going to try sample equals 30. Let's try that, see if that'll do anything. Oh, you know what? That won't work. Sorry. Yeah, forget I said that. But clusters, that's the argument. But I'm not going to go 30 because it's going to try to panel 30. So I'm going to go maybe 10. It'll give me 10 panels, but that's okay. Let's go ahead and look at this, shall we? All right, so what am I looking for here? I'm trying to see if the 2 models are generating drastically different predictions. So for Jedi 2, they do differ, and it's easy to see that they differ. But Jedi 28, they don't differ. 32, they don't differ. But 69, they differ, and 94, they differ. So occasionally, it seems to make a difference. Is it a large difference? I don't know. At this point, I'm not entirely sure, just from the visuals, if it's worth keeping that random effect or not. So that's especially when we start resorting to statistics, when it's visually ambiguous. Although we often resort to statistics even when it's not. But anyway, so we'll do the model comparison. And what does this tell us? We get the same sort of model comparisons before. And by the way, that's amazing. That's awesome. That was intentional. That's probably one of the smartest things I've ever done in my life, is that the visualize and compare.fit and model.comparison and estimates, all these functions work on linear models, they work on generalized linear models, they work on random forest models, they work on mixed effect models, and there are some models that it won't work on, but if there's a type of model that you want to run and it doesn't work, let me know and I'll try to make it work, because that's the idea, is that we use the same functions no matter what kind of model it is, because we always want to investigate the estimates, we always want to be comparing models, we always want to be visualizing things. So yeah, brilliant, but this is how it works with mixed effects. Anyway, AIC is favoring the reduced model. Is that right? No, sorry. The smaller number, 8809, is smaller than 8878. So it's favoring the full model. The BIC is favoring the full model. The Bayes factor is daggum super favoring the full model. And the p-value is daggum super favoring the full model. And the predicted differences, as we saw in the plot, most of the time it makes very little difference. And then R-squared change, we're not going to talk about that much right now. So even though the visuals were kind of ambiguous, it was kind of hard to tell whether it was worth it. Basically what the model comparison is telling us is it is absolutely worth it. You totally need to keep that variable, or keep that as a random effect, because even if it is a small effect, it's a consistent small effect. So here I write, doth my eyes deceive me? It seems as if we shouldn't get rid of the random effect. Yes, our eyes did kind of sort of deceive us, and that's okay. That's why we use visuals and estimate and statistics together. So at this point, I'm feeling pretty good that we have a good fitting model. And at about this point, I'm going to go ahead and look at the residuals of the model. And we interpret these just like we would a regular one. So the histogram of the residuals looks gorgeously stunning, my dear. Although we do have some skew, or some outliers really, on the left side. And then the residual dependence plot, there's a little bit of bending, but that's very common. That, for the most part, looks flat. SL plot looks flat. Man, these are gorgeous residuals. So by golly, I think we have a beautiful, lovely model. So that's great. And then remember I said earlier, I'm not going to interpret it now. Why did I say that? That's kind of a habit that I've developed. I don't want to prematurely interpret the results of a plot or the results of the estimates or anything like that until after I'm confident that I have a good model. So now that I've gone through the model comparisons and the visuals and the estimates, actually I haven't looked at estimates, but I'll look at that in a minute. I'm pretty confident that we've got a good model, so I'm ready to start interpreting. So now I'm going to basically, what I had before, I'm going to copy it down here, and then I'm going to look at the plot and ask myself, what does this mean? So let's make that big again. And so let's return to our original research question. So the Jedi Council seems to think that if you form emotional bonds, regardless of your natural inclination to be angry, you're more likely to become a Sith Lord, or you're more likely to have darkness in your soul. And by golly, it seems that is the case. So this visual is controlling for, what did I say? Emotional bonds. No, anger. So this is controlling for anger, and it's saying that on average, increasing emotional bonds actually increases darkness. So the Jedi know what they're doing. I don't know why we ever doubted them, honestly. Trust the Jedi. That's what I always say. All right. And then let's go ahead and look at the other variable, anger. And I'm not paneling these because I don't have to panel them. It's easier to interpret things if I just look at a simple bivariate plot. I mean, technically it's not bivariate because I still have the, what do you call it? The cluster variable in there. But here's the darkness and anger relationship. And again, that is kind of striking. So yeah, the more angry you are, the more darkness there is inside of you. So obvious, but it makes sense. So yeah, that's awesome. So I had a lot of fun analyzing some Jedi data. Man, those Jedi are awesome. They give us good data sets. So that was a brief introduction into using Flexplot for mixed models and how the standard functions that we've always used, the compare.fits and visualize and model.comparisons and all that, how or what information they reflect when you're looking at mixed models. So I've got several other videos that I will link in the description that go more into depth in a lot of these things. So yeah, I guess that's all I have to say. And yeah, in celebration of the Jedi, let me just say, may the Force be with you.